Another measure of spread is something called the interquartile range, which a lot of times we abbreviate IQR. And what it is just the difference between the third quartile and the first quartile. So you just subtract those two. Another vocabulary term is something called an outlier. An outlier is a data point that just doesn't fit with the rest of the data points. It's really, really big or it's really, really small. Now, there is, in statistics, we do have a formula, although I like really, really big or really, really small. You can justify it that way. But what a lot of times we'll do in algebra, we're going to say an outlier is determined by, it's going to be the median plus or minus 1.5 times the interquartile range. So if you take 1.5 times the interquartile range and add that to the median, anything bigger than that number is going to be considered an outlier. Anything smaller than 1.5 minus the interquartile range is also going to be an outlier. So here's what we're going to do. I've got this table. I want you to identify any outliers in the data. So first off, I'm going to calculate most of my 5-number summary. And I'm going to use the calculator this time. So I'm going to find the median first. So in Desmos, I've already typed these in to save us some time in the video, but I would suggest you pause the video and type those into a list. Okay, welcome back. Now, in the functions, our median is in the first column, second row. We're going to find the median of x1. Well, the median of x1 is 17.5. So I'll write that down. And then I'm going to do quartile 1. So when you find quartiles on Desmos, your first quartile, you go to functions, and we're going to look at quartile, which is in the third row, first column. And you're going to type in x1, and that tells us the data point. Now it's going to say which quartile. Well, we want to find the first quartile. Your first quartile is the lower quartile, and that's 15. Then we'll do the third quartile. And I think I'm just going to erase the 1 and put a 3 in there. And that's 24. Notice the first quartile is 1. The third quartile is your 75%, your upper quartile. I wonder what quartile 2 would be. And notice that's your median. Now we look at our data. By the way, we probably could have answered this question without doing all this work. Because if we look at our data set, which ones don't belong? Well, to me, that 40 looks suspect. I'm going to highlight that 40 for right now. So here's what we're going to do. We're going to find our interquartile range. So our interquartile range then is 24 minus 15. Well, 24 minus 15 is 9. Then I'm going to take 1.5 times your interquartile range. So 1.5 times 9 is going to be 13.5. Now, let's take our median, which is 17.5. I'm going to go plus or minus 1.5 times my interquartile range, which is 13.5. 17.5 minus 13.5 is 4. Well, do we have any numbers in our data set that are below 4? No, you don't have any lower outliers. Now let's take 17.5 plus 13.5. Well, that would be, what is that, 31? And notice 40 is bigger than 31. You don't have any other data sets that are more than 31, so we only have one outlier. Now we want to find the mean and the median of the data set with and without the outlier. So, and then we want to describe its effect. Okay, so let's make a table here to represent what we want to do. So I'm going to find the mean and the median, and that's with the outlier and without. Well, we already know with the outlier, because we just did it, our median is 17.5. Let's go into Desmos and let's find the mean of that data set. So I can type in mean, but I don't like to type, so I'm just going to press my function key. I'm going to find the mean of x1. And the mean of x1 is 19. So now let's get rid of 40. So go in your table and let's just get rid of that row. Now we'll do the same thing. Let's find the median of this data set. Sorry, my pen died. Okay, so we're going to find the median of x1. And notice that's 17. That kind of makes sense. It went down a little bit, didn't it? Because we took off one number. Let's find the mean of x1. Notice that went down a lot more. That's about 17.8. Now, if your mean and median are relatively close, that means your data set is pretty symmetric. But notice what happened here. That 40 really affected the mean, didn't it? So what we can say then is we remove an outlier. Let me change colors here. Removing an outlier affects the mean more. And this has a practical application to you right now. If you taking a class, and most teachers take the average, but I think you could justify that, hey, if you did really, really bad on one test, let's say you were sick and you didn't study, and you failed it big time, but all your other grades were pretty good. Well, what happens is that one outlier is going to drag down the rest of your scores, and you could maybe justify to your teacher, hey, do the median. Find the middle of my scores, because that's actually more representative of what you know.